When using React 3 Fiber, we just put all our 3D scene inside a canvas and it is rendered into the screen. But if you come from a Three.js background, you know we have a bit more work to do before being able to display things into our screen. We need to create a WebGL renderer. It will take the scene and the camera to display it into our canvas. Fortunately, React 3 Fiber does it automatically for us, but it's good to know how it works for more advanced use case. What the renderer does is it will take our 3D scene. Let's say this cube is a 3D scene. So it's all our scene here. We have, I will change the color. We have our camera viewing the whole scene. It will convert this 3D scene into what we see inside our screen. To understand what are render targets and how we can use them to create advanced effects, I prepared this 3D scene containing the 3D model found on Polypizza. My avatar from Ready Player Me, it's the same we will use inside the final portfolio chapter. And I created this UI in the bottom right to be able to switch between different screens, to do a security camera systems that we will render inside this TV screen here instead of SpongeBob SquarePants. Let's start by creating the first one, the corner one. We want to create a camera in the corner of our scene, displaying the scene inside the TV. To create a render target with React 3 Fiber is very easy. We can do corner render target is equal to use FBO. It's coming from React 3 Dry. If you are curious about how it works under the hood and what are the different parameters, I recommend you to check the source code inside Dry library to see what are the defined types and what it's really doing using Three.js. It will help you get a deeper understanding, but it's very optional if you get the React part. Now we have our render target here. We need to say to our renderer to render the scene inside that render target. Because we want it to be live to see the animation of the character, we will do it at every frame. So use frame. And to access our renderer, it's inside GL. It's in our 3 state. But we can access it from the callback function of use frame. It's GL. Or you can get it doing const GL is equal to use 3 state GL. It's the same variable, but we don't need to get it here as it's already coming in the useFrame callback. We need to do gl.setRenderTarget, and we use our render target, so corner render target. Then we need to tell it to render. It will be the scene and the camera. We also get them from the 3 state, so scene and camera. Here it is the default camera. For now it's good. So scene and camera. And after, we need to release the render target, so it will render it automatically into the canvas. gl.setRenderTarget to null. So far, it doesn't do anything because we have a render target variable, but we are not using it. We want to display it onto the screen. We know it's the one displaying the video here. Instead of displaying the video texture here, we will create a ref to it. Let's name it TV material. We create a reference named TV material. And inside our use frame, we will assign it TV material .current.map is equal to corner render target .texture. Now we can see our scene from the same camera, but displayed on the TV. But what we can see is that on the TV screen inside what is filmed, it is just displaying nothing. This is because at the first render we do into our render target, nothing is displayed on the screen. Let's try to create an inception effect of infinite rendering. To do it, we will need to create another render target. Let's name it buffer render target is equal to use FBO. Then first, we will render our target to the buffer. We do the same. We render the scene and camera, and we assign our TV material to it. Then we assign the second render target, the one we were using before. We do the rendering, but this time it will have the TV material set to what we saw at the first render. And then we assign the TV material to the second render target. Now, if we look, On the screen, we can see another screen and another screen. It's nested infinitely. If you have a hard time understanding what is happening and why it's giving us this result, you just have to go step by step what the renderer is doing. Instead of having that realistic infinite loop effect, we will get rid of it and we will display SpongeBob SquarePants on the first render. So tvMaterial.current.map is equal to video texture. So when we will do our renderer, inside what the camera will see, it will be the episode of SpongeBob SquarePants. And what we will render will be our scene with SpongeBob SquarePants displayed on the screen. And this is what we have currently. We see our scene, and on the screen we have our scene from the camera, but magically it is watching at SpongeBob SquarePants. So far, we have used the same camera. So when I rotate it, it's also rotating on the screen. What we want is to have a real camera system. So when we will press the different button, it will show it from the right place. To do this, let's create 3 different cameras. So one will be really close to us. It will act as the front camera, so coming from the TV. Then a second one will be on top of our scene, so only on the y-axis. We'll assign it a top camera reference. And the last one will be our corner camera. Let's declare the different reference and render target for them. So we will have front camera. We'll create a front render target. We'll have a top camera. We'll create a top render target. And we have our corner camera. And we already have the corner render target. Now to know what camera we want to display on our screen, I created a hook. We get the mode from it, and the hook is use remote. If we have a look at what it does, it's a simple state with the different mode accessible. In the remote component, we can have TV, corner, top, or front. Now what we will do is we will declare a current screen texture. And by default, it will be SpongeBob SquarePants if we are in TV mode. Then, if our mode is different, so if it's front, our current screen texture will be front render target.texture, and we'll have to change the rendering main scene from the front camera. So we can take this, and it will be slightly different. We want to render to front render target. We want to render our scene, but we could use a different scene. And the camera we will use is the front camera.current. We repeat the process for each camera. If it's the top one, top render target, and top camera. We do the same for the corner one, corner render target, from the corner camera, corner render target, and corner camera. We are not using the default camera anymore, so we can get rid of it here. And now what we need to render into the screen is current screen texture. Now if we try, we have the TV mode by default, so it's working. But if we switch to corner or top, we can't see anything. It is because our camera position is correct, but where they look at is incorrect. By default, the camera are looking in front of them. We will change it by updating where they look at. So top camera.current.lookat vector 0. It's already present here. It's just a vector of 0, 0, 0. We do it for each camera. Corner camera and front camera. Now let's try it. We render from the corner camera, so we can move, but it's not moving. It's another camera displaying our scene. And the top one, we can see our character from above. And the front one, it's like the camera is inside the TV. It's a bit creepy, but it's a nice effect. Let's add a funny effect to show you really what you can do with the render targets. Because the scene is rendered and then it's re-rendered for the final one, we can do pretty everything to render completely different things inside our TV. What we will do is, if we are in front mode, before rendering it, we will want to open the mouth of our avatar only inside the TV. So we will call scene.traverse to go through all the different nodes of our scene. If we find some morph targets, it's inside our model to be able to animate some facial expression in our case. So if we have morph target influence and it contains mouth smile, we will set it to 1. And same for mouth open. Then we will reset it before rendering the normal render target. So when we set it to null, reset mouth of the avatar, and we will set it back to 0. So in our scene that we are displaying with the main camera, our avatar won't be smiling, but only what the camera that is filming us from the front, we will see our character smiling. Now inside our TV screen, our character is smiling. But if we look here, our character is completely normal. So this is one of the ways you can use to create nice effects with render targets. But of course, you can do way more using render targets. For example, you could display another model next to our character to make it like a horror movie. Display it in black and white or in a night vision mode, and you are not forced to render the target inside a TV screen. You can render globally the render target. So it will help you create some transitions between scenes or create some custom post-processing effects. With the render target, we have seen how easily we can render our current scene into different targets to create nice effects with the same scene, but use different variation or camera point of views. But Dry Library provides two useful components if you want to display other scenes within one global scene. You have the render texture. What it does is it renders a separate scene inside a texture. So all you see inside render texture, it's a custom camera, custom lighting settings, and it will attach it to the mesh of that box geometry you see here, creating this nice effect. I made a video covering it on my YouTube channel. You can find the link in the text content from this lesson. The second component you can use is Mesh Portal Material. Under the hood, it's using Use Texture, but it's providing additional effects such as the blend to blend from one word to another one. A good example is this one here. You can see we have our main scene containing those 3 planes, and inside each of them there is a custom scene. And the difference between Mesh Portal Material and Render Texture is that the portal reacts to our camera position, so it gives us the illusion we are looking through a window. And the second one is we can blend from one word to another nicely, creating nice transition effects. I also made a video covering it. You can have the link inside the text content. You now have a good understanding of what render targets are, how it works, and how you can use them to create nice effects. We've done a very basic and simple example, but it opens a lot of possibilities. If you want to dive deeper into it, I highly recommend you the article from Maxim Haeckel. It contains very nice render target effects.